What is respiratory rate? Respiratory rate is the number of breaths you take per minute. The normal respiration rate for an adult at rest is 12 to 20 breaths per minute. Various conditions can alter a patient's normal respiratory rate, including asthma, pneumonia, anxiety, lung disease, and numerous others.
Why is it important to be able to measure respiratory rate? Respiration rates may increase with fever, illness, and with other medical conditions. These conditions can be detected more easily based on respiration rates.
How will the breathing rate be measured? For this case, a Thermistor respiratory rate monitor is used to measure the breathing rate.
What is a thermistor? Thermistors are resistors sensitive to changes in temperature, whose main function is to exhibit large, predictable, and precise changes in electrical resistance when subjected to a corresponding change in temperature.
Why is this method being used to measure breathing rate? This method is being used as it requires a simpler input than other devices such as chest force sensors, impedance pneumographs, and pulse oximetry devices. Thermistor breathing rate devices are a cheaper, reliable, and versatile option. The ability of the thermistor to have a changing internal resistance allows for a voltage change that is substantial enough to be measured accurately. This then leads to the calculation of the patient's breathing rate.
What is the biosignal input? The biosignal input is the change in temperature or heat produced by the patient as they breathe into the mask containing the enclosed thermistor. The resistance of the thermistor decreases when heat increases, which can be used to manipulate the voltage entering the system.
Thermistor measurement circuit diagram. This circuit contains a simple voltage divider to drop the voltage from the power source battery. The input voltage is on the far left, and VTH, or the voltage across the thermistor, is what will be continuing to the filtering stage. RTH, or the resistance of the thermistor, will be changing as the patient breathes, affecting VTH. The voltage divider equation is used to find this change and is shown on the screen. Thermistor amplification circuit diagram. From there, the signal must be amplified in order to have enough of a voltage difference from when the patient is inhaling and exhaling. To do this, a high-pass filter with a gain of 4 is used. This high-pass filter also serves to remove DC offset and lower frequencies from the signal, in addition to reducing noise. Voltage can then be calculated from the equations shown on the screen. Port A0 leads to the analog to digital converter, while port B2 is the positive reference voltage pin for the analog comparator. Analog comparator circuit diagram. The output of the previous op-amp goes directly into a comparator op-amp. This device compares two input voltages and outputs the larger voltage. This circuit also acts as a low-pass filter. When combined with the previous circuit, this creates a band-pass filter.
LCD display circuit diagram. The output of the analog comparator goes to an LCD. This LCD is powered by a user-controlled switch that will neatly display the patient's final breathing rate.
In conclusion, it has been determined through a retrospective study that respiratory rate monitoring is better than measuring heart rate or blood pressure for predicting which patients are at risk of cardiac arrest, showing the magnitude of importance why respiratory rate is measured. This thermistor-based respiratory monitor is a reliable way to ensure accurate results in a compact, low-cost device.